As a prepper, I'm not too fond of the idea of electric cars. And the reason for that is that I expect that electric cars not only require the grid to run, which will probably be down, especially after a grid down event, but moreover, because they may actually catch fire when you have an EMP event, because there's two things that can set the batteries into thermal runaway on an electric car. One of them is being dendrites that form between the anode and cathode within the cells of the car, the electrical battery cells, which most of them have these little 18650 battery cells, which are kind of like an oversized AA cell. And furthermore, they can go into thermal runaway if they get overheated, which is an event I would really expect in an EMP event, especially if they're plugged in and charging while that's happening. A lot of people have charging stations inside their house. I'm going to show you in a minute just how bad a Tesla can go boom. And I'm going to have to ask you, do you want this in your garage when this happens? I think it'll take your house out in seconds. It will not be pretty. These batteries are very explosive. What a lot of people don't understand is one of these batteries can go on thermal runaway just sitting on a shelf. They can grow those dendrites, and once they make a short circuit between the anode and the cathode, they start to discharge current internally, and then they overheat. So they can get the overheating from that or from some other external source. Either way, this spells trouble for these cells. And they have enough oxidizer in the metal oxide cathode of these cells to actually consume up to 15% of the flammable electrolyte inside before the shell even ruptures and it gets access to any oxygen outside. It's already a bomb. It's like a torch, a big blowtorch, or a rocket motor, you might say. Yeah, I know a little bit about rocket motors. Each one of these cells, once it goes off, can set off the adjacent cells. There's a lot of different safety precautions that can be taken to help mitigate that, but it doesn't prevent it. So, and as you can see, it does happen in the Tesla cars. It happens a lot in the Chinese electric vehicles. The Teslas are a little better quality, at least so far. Of course, they also get a lot of their batteries and things from China. But I'm going to show you the thermal runaway of a Tesla. But moreover, the whole value proposition of these vehicles is that they're supposed to reduce the carbon footprint and make the world a lot better for climate change. Well, there's a study out now that really puts a big shadow on that. It says that they may actually have a bigger carbon footprint than gas-powered cars. So that may just nix the whole thing. Not only that, being heavier, they actually are subjected to putting out up to 20% more tire particulates into the environment. And those are actually toxic to fish, various aquatic life, and even getting the plants you eat. So I'm going to go into that too. So these cars, and not to mention the moral issues of having used the child labor that mines the cobalt and the Congo, perhaps slave labor used in China, or like I said, the child labor in the Congo, either way. And there's just a lot of issues, ethical, environmental, that have not been properly addressed. And the other thing is that we're just kind of forcing the entire system into this. We're disrupting our entire industry, our infrastructure, and we're putting a lot more pressure on our delicate, overtaxed, not hardened power grid. Already we're looking at brownouts with the temperature extremes we're having because we're cutting back a lot of the non-carbon friendly power sources from our grid. And our grid is struggling as is right now. And yet we're putting all this extra demand on it. Of course, the people are hawking this, oh, no, it won't cause any more problems. Well, how is it when your grid is already overtaxed and you're taking a lot of the power production offline, you're not going to have problems. We're already having problems. We're already having brownouts. And we're worried about places like Phoenix not being able to have AC in a real heat wave. If the power goes out there, it may cost lives, maybe lives. And we almost had a tragedy in Texas a couple winters ago, winter before last, in which because there was snow on the actual solar panels and the wind turbines were frozen up and couldn't move. They weren't getting the power production they needed when they needed it. So that's the problem. It's when you need it the most, you got it the least. And that's what you got to worry about. When you need it the most, you got it the least. So that's part of the issue here that we got to deal with. And so let's go and look at some of this stuff. I'm going to show you this battery. Yeah, I think the value. Oh, another thing. See, when it comes to prepping, I got 2 trucks. that are both in the 70s. One's a 76 and one's a 79. I expect either one of them will run just fine with the grid down. So if you got older vehicles, and in fact, a lot of your other gas-powered vehicles, are basically Faraday cages. They got a pretty good chance of surviving. Your electric cars are nothing but a computer console with batteries. They're so electronic. I really would be suspect of their survivability. Not only that, because they're so much heavier, they're also a bigger road hazard in collisions. Oh yeah, in collisions, you can also get thermal runaway with those batteries because you mess up those cells and get the anodes and cathodes contacting, boom, 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 boom. Wow. So let's have a look at some of that boom, boom, boom. We're going to go here and do a screen share and look at thermal runaway case. This is from a Facebook article, a Facebook posting here. It looks like an Instagram posting. And I'm going to play this briefly just to give you a sense of what this looks like. This is a Tesla car down here, by the way. So let's see here. Look at that. Look at that, guys. Yeah, the sound has been shut off here. There you go, guys. Is that ugly? What would that do inside your garage? Boom. Yes. Do you want this in your garage? See, it's flinging parts over. Do you want to be in this? Do you don't want to be anywhere near that? That's enough play. I'm not going to play any more of that. So I'm just don't get a copyright strike. But guys, do you want this in your garage being charged up and then boom, grid goes down? You may have problems. Your house might want to burn down anyway with all the extra charge in your power lines. But this is something I find disconcerting. And especially when the reasons we're doing it for are being challenged, like right here. This is an article. Electric cars might not even lower carbon emission findings according to this report. Now, I'm not going to be able to read you this report directly, and I'm not going to be able to, just scroll through it because I don't want to get a strike for copyright. So I'm going to kind of give you my summary of what this says. But anyway, what this report says is that the environmental benefits of electric vehicles have been subject of intense debate. While it is true that EVs do not emit exhaust fumes, a recent report suggests that the carbon footprint of manufacturing of these vehicles might offset their supposed environmental advantages. The process of creating electric vehicles involves mining, processing, and refining materials that generate a significant amount of carbon dioxide. That carbon output is reportedly significantly higher than that associated with production of traditional gasoline-powered vehicles. So furthermore, the electricity used to charge the EVs often originates from fossil fuels such as natural gas and coal. Get that, guys. Mark Mills, a senior fellow at the Manhattan Institute, argues in his report that these factors reveal a critical weakness in the logic behind the push for electric vehicles, such as those proposed by President Biden's administration. The Environmental Protection Agency under the Biden presidency announced a rule that essentially necessitates the transition to electric vehicles. Actually, 2/3 of all vehicles sold by 2032 are supposed to be electric. However, Mills' report challenges the validity of these mandates and other claims that the EVs will significantly reduce carbon emissions. The report emphasizes that any assertions about EVs reducing emissions is based on rough estimates, averages, aspirations, and not on concrete data. The uncertainties and variabilities in the emissions from these energy-intensive mining and processing of materials for the EV batteries significantly affect the overall emissions calculation. The report highlights that many forecasts incorrectly assume that the minerals for these electric cars are sourced from North America, where the power grids are cleaner. In reality, China refines a significant portion of the world's energy minerals, about 50 to 90%, and the emissions from the Chinese refineries are considerably higher than those in the United States or in Europe. Consequently, Mills presents scenarios where the lifetime emissions from driving an electric vehicle could be higher than those from a gasoline-powered car. So, they use dirty coal, lots of it over in China. Despite the environmental concerns raised by Mills and warnings from car leading manufacturers and influential unions and such, the push for electric vehicles continues. However, the American public remains skeptical. So what would you think? A poll conducted in April reveals that less than a fifth of Americans are likely to consider an electric vehicle for the next purchase. So not that many people want them, but they're about to be foisted upon us, pretty much sans whatever our will in this regard is. Now, what do you think about that? Do you think that is fair? Do you think this is the way we ought to go and the way we manage our our automotive fleet to have be forced into this? Now, some people say, oh, it's from the environment. We have to do it. If we don't do it, it's going to be the end of the world. End of the world as we know it. Well, I don't know. Some of us differ on that. But it sounds like the entire proposition for which the transition is being foisted upon us has been called into question, along with so many other questions like, can our grid handle it? And I've chaired 2 power grid defense conferences. I am an electrical engineer. And so you think I'm all for electricity. I'm for things that work. I'm for practicality. And so there's some real questions to do with this. So now let me forward this over to another article here. We're going to, oops, got to move this around. It's not going the way I want it to. I got to fight my Zoom tabs. Oh, trying to move it down. It's going up. Jeez. All right. This is the, we skipped ahead a little bit. This is the Volkswagen, what is it, Volt? I believe it's, no, it's not Volt. Volkswagen e-Golf. This is an economy car, the Volkswagen e-Golf. We're going to talk about that briefly here because the gasoline and the electric vehicle version, even though it's an economy car, differ almost a ton in weight. It's actually 880 pounds different, 400 kilograms. So this article here talks about the tires, a lesser known pollutant headache, which will be worse with electric vehicles. The environmental impacts of electric vehicles are subject to intense debate, as we were seeing now, right? But the pollution caused by the tires is often overlooked. Electric vehicles are considerably heavier than their conventional counterparts due to substantial battery packs they carry. Even for an economy car, such as this Volkswagen e-Golf that we just looked at, like I said, it's about 400 kilograms, 880 pounds bulkier than the gas-powered version of the Golf 7. This additional weight accelerates tire wear, leading to increased release of particulate matter in the environment. Also, the electric vehicles get more torque, and more torque also gives you more tire wear. Now, torque is fun in a vehicle, yeah, sure, but it is more wear on the tires. To provide a clearer picture, the average car sheds about 4 kilograms or 8.8 pounds of tire particulates annually. Given the extra weight of electric vehicles, this is expected to be even higher. There's about 6 million tons across the entire global fleet of vehicles of these materials. And so we're expected to increase by about 26% with electric vehicles. These particles, once released, can infiltrate water bodies, posing a threat to aquatic life. One of the harmful chemicals emitted from the tire wear is 6-PPD, a derivative of common tire rubber preservative. This chemical is particularly lethal to salmon and other fish species, causing significant mortality rates in these fish. It is absorbed by edible plants such as lettuce and is found in, you know what, human urine. No kid. The presence of 6-PPD on our highways is a growing concern, underscoring the need for more research and potential regulation of tire composition. And so it's even bigger concern with these kind of cars. Here's another article where the writer here is saying, hey, our green transition is totally fake. And, you know, they're going into just a whole lot of stuff about these windmills. And, you know, there's a lot of challenges. I'm not going to go into what this article says. But, you know, some people think that there's the windmills are causing other problems, such as they think maybe where we're putting them offshore, the sonars used and the blasting used may cause the death of whales. The people for this have, said, no, it's not true. This isn't happening. Just like it's not going to put any extra tax on our power grid. I guess they're right. It can't be why there's an increased death rate in whales while they're out there dynamiting and sounding to put these things offshore. Hopefully they're far enough offshore that the blades won't chop up as many birds. I don't know, guys. Oh yeah, don't we have a shortage in birds today? And of course, there's tons of videos and materials out there about these things catching fire, about these things burning. This ain't gonna play, but anyway. So just give you an idea that there's a lot of videos with these things catching fire. So the reliability is to be questioned. I'm gonna stop the share. Hello. Yeah, the reliability is questionable for the wind turbines as designed. Now, I'm associated with a group that's coming up with a wholly different wind turbine design. It ain't gonna be anything, not a 3-blade turbine, nothing like that. It's gonna be a lot better. But what we're dealing with right now has got a lot of issues, a lot of problems. And this wholesale jump toward electric vehicles, given that we really don't have good electrical storage and toward the electrical vehicles and also toward trying to be total net zero renewable in our electric grid power generation, we're not there yet. We don't have the technology for it yet, or we don't have the systems in place. Now, if nuclear power had like the mini reactors that would be available at the plants or something like that to keep the power running in case of other natural disasters, which might take out either the backup diesel generators, an EMP, or the lack of ability to get fuel to those generators, or like the floods at Fukushima, or it could be in other places. Many of these are close to water, like an upstream dam breaking, which might wash out the generators. Yeah, we got to have backup power. We got to have reliable backup power to keep the reactors and the spent fuel rod pools cool. And we need to reprocess those spent fuel rods into additional fuel instead of buying fuel from Russia and everywhere else. So a lot needs to be done if nuclear power is going to be used. The way we're using it today is not. Everybody says, "Oh, it's safe. It's safe." I hear it so much. Well, yeah, the reactor itself can be safe. I worry more about spent fuel rod pools, and I worry about some other things. There's a lot of times when people tell you they're not looking at the whole system aspect for what happens when the entire grid goes down. They're looking only if this fails here. They're not looking at it from a true system engineering, system safety standpoint for what it takes to really maintain the full wide range operation of these with societal collapse. That's the kind of thing I look at when I look at grid down scenarios as a prepper. And so I'm saying that's one technology that might work, but a lot of work's got to be done, a lot of political hurdles, and got to be over a lot of industrial resistance because the guys that make and sell the fuel don't want you to do the right kind of things. And, there's just a lot of issues out there that's got to be cleared out before I feel comfortable with moving forward with that technology. But there are potential advantages and things can be done, but we're not ready yet to give up coal and natural gas and petroleum. As a matter of fact, we're moving a little too fast, in my humble opinion, toward electric cars. I think we need to slow all this stuff down. We got to get better battery technology. Now, on the other side, there is the development of these solid-state batteries. They are much safer than lithium-ion batteries, but you're still going to have the weight. You're still going to have the manufacturing issues, and it's still going to be a question is, are they leaving actually a negative carbon footprint? The way everything is manufactured today, the answer would probably, it's very likely, very likely. I'm not going to say definitely one way or the other, but and that's not the only study I've seen that's challenged this. This is just one that I brought up. I've seen other things put out there that made similar challenges. So the question is open. The analysis is not, really full range on this. It's been very narrow range with a lot of assumptions made, which according to that paper are not valid assumptions. So you tell me what you think, but it's still, even then with the grid down, especially if you have an EMP, is that vehicle going to be safe? Are you safe? And if it don't go into thermal running, because now you got a lot better battery, is it going to operate? I think still the vehicle was likely to be taken out by an EMP. Oh yeah, and there's this other thing. Once you get 100,000 miles on it or something, whatever it is, you got to replace the battery. So you go through the whole manufacturing thing again. You got to replace the battery. Those batteries are extremely expensive. So if you buy a used electric vehicle, it's not like buying an old used gas vehicle. You can get it for a few $100s, maybe a couple $1,000, depending on where you buy them. I usually buy them once they're really used for like $1,200. That's about what I use. Unless it's a truck, I'll pay more for a truck. But guys, your batteries are going to cost so much on that old vehicle to replace it. It's going to be you're going to have to lay out a lot of money, and then you got to pay on top of that to charge it. And electricity rates are not going down, so especially as they're getting more and more renewable, it seems like the rates are going up. The power availability is down, and let me even tell you, don't charge your cars right now because it's hot or it's cold. Yeah, and what happens when you're up in the great north and you're in a blizzard and get stranded? You can't run your motor to stay warm. There's just so many issues with these vehicles to have it thrust upon us that we have to change so much. The fleet is a bit much. Now, I ain't got anything against people buying them because if that's what you want to drive around, fine. But I think to have that's your choice. As long as there's a choice, I'm good. But to have it foisted upon us, thrust upon us at this point in time, where our technology and our systems are so weak in this area, I think it's highly questionable. And I think this does apply to us as preppers, because I question the safety of them. I question the effectivity. Will they run after a grid down? Not just from the standpoint, can you get power, but will they be fried? Are they a lot more susceptible to being fried by an EMP? You might even get fried by CME if they're connected to the grid while you're charging. CME has the E3 waveform. It's a longer waveform. The car itself might not pick it up. It would pick up like an E1 from a nuclear device, an EMP. But from a standpoint of a E3 solar coronal mass ejection impact, it may not fry the car itself unless it's plugged in and being charged. But a lot of them would be. And it would be maybe in people's houses. And then they might go into thermal runaway. I don't know if the solid states are good for a CME type event or not. They're good for normal everyday things. Yeah, the solid state battery is a far better battery, and they are doing some battery technology, but where does it really leave us? I don't think we're ready for this. I don't think we're ready to be forced into having 2/3 of the fleet go electric by 2032. Now, maybe things will change in a hurry, but I'm not seeing the right stuff changing in the right way fast enough. You tell me what you think. Tell me below. Maybe you think I'm just totally missing something, so educate me if you can. Anyway, hey, I'm gonna say, if this gave you value, please subscribe to my channel, bang the notification bell, and click all. And oh yeah, because we got a lot of monetary questions coming up these days, or things going. I suggest you check my CBDCs coming out, or dollar getting devalued. Check out the link below to Defy the Grid, where you can get Goldbacks, this printable money that's printed out in bill form. That's actual gold. It's not a note you can trade it for gold. It is gold. And you can get gold coins. You can get gold bars and other stuff. Defy the Grid. Check my link out below. Anyway, thank you for watching. And with that, I'll say, Greg out.